Hello, we are going to talk about example 38, and it says the weight W in grams of female sparrows is modeled by a normal distribution with mean mu and standard deviation sigma. First bit of information it gives us, it says experimental data shows that 84% of the birds weigh at least 20 grams and 44% of the birds weigh more than 22 grams. It wants us to calculate the values of the mean and the standard deviation, correct to 5 decimal places. So let's set up our expressions first with the information we know. We know that the probability that the weights of those sparrows, if it's at least 20 grams, then it has to be greater than or equal to 20 grams. And that's going to happen 84% of the time, so it's 0.84. Now, 44% of the times, it's going to be more than 22 grams, so it's probability that it's more than 22.5. That's going to happen at 44% or 0.44. Now, to be able to use our inverse, which we're going to have to do to normalize this, we can't do this for greater than. We're going to have to do less than. So the probability that our weights are less than or equal to 20 is 1 minus this, and that's going to be 0.16. And the same thing is going to have to happen over here. We don't have greater than to be able to do our inverse. We can't do the inverse for greater values greater than that, so the probability that W is less than 22.5 is going to be 0.56 or 56%. Now we can normalize, right? And if we normalize it, we go 20 minus our mean over our standard deviation, and our inverse notation works like this. This is our normal inverse. The same thing over here. It's going to be 22.5 minus our mean over our standard deviation, and we're going to take the inverse of this at 0.56. Good? And then now I can go to the calculator. So I'll go to the calculator, and I'm going to find out what this value is, right? So I'm going to go menu, probability, 5 distribution, inverse normal 3, and I have 0.16 right here, and it comes out to negative 0.99455. So what I'm going to do is I'm going to assign this. Hello, had a little technical problem there, so I think I figured it out. So next, where we left off, I'm going to let this value here equal A. So in this calculator, I'm going to store this as A. So I'm going to go store A, just be easier to work with. And now that value, this negative 0.994457 and so on, is stored as A. And then I can actually solve this equation by multiplying by our standard deviation, and then I got 20 minus mu. Right? Same thing is going to happen over here, but I'm just going to find out what my inverse of 0.56 is, normal inverse, and I can just do a quick little edit here, and I have that value, but I'm going to store that as my letter B, and then I'll have B times my standard deviation, which is, and I'll have 22.5 minus mu, and real quick store that as B, and there you go. And now I have a systems of equations. My A and B are constant numbers that I've stored as these values, and now I can use the calculator to solve this, and I'll go algebra and solve a systems of equations. I get 2 equations, 2 unknowns. I'm actually going to, you could keep it as x and y, but I like to keep things straightforward, so I'll use m for mu, my mean, and I'll use d for standard deviation. And I'm going to plug this equation in. So I go 20 minus my m. That's going to be equal to my a, which I've stored, times my standard deviation. Put my other one in here. It's 22.5 minus my mu equals b times, plugging this equation in, b times my standard deviation right here. And then I got my answers, right? So, and there you go. So my mean is going to be equal to, that's the first guy here, so it's about 22. They said 5 decimal places, so 1, 2, 3. That's going to be 17049. So it's actually going to round up to 1, right? So, or better yet, 0.05, right? So there we go. And then our standard deviation is 2.1826 if we round up to 5, right? So, or better yet, 1, 2, 3, 4, 5. Yeah, I guess it just stays 259. My bad, and that's 5 decimal points. Either way. So there you go. Now, so that's A. We found our mean, our standard deviation for the sparrows. Now B says a random sample of 5 sparrows is collected. If B denotes the number of birds in the sample, what weight that weigh more than 23 grams, calculate the probability between here. If you don't notice for B, so we did A up here, B is a binomial. They said let it be B is a binomial distribution. We have 5 trials, but we don't know the probability of success. But we said they kind of gave it to here. The probability of success is going to use A, and it says the weigh more than 23 grams. So you want the probability that W is more than 23 grams, right? And that will be our P, right? So now I can use the calculator with the information I have up here, right? But real quick, I can go up here and I want to use this number here. If I tap on it, I can go like this and then store that. That's my mean, right? Store that as my mean, and then I can do the same thing right up here. Tap on it, and store that as my standard deviation, and then I can find this probability to find out what my P is. My P, I'll go 5 probability distribution, and then I got a normal CDF that's 2, and I'm going to start at 23, and I'm going to go up to 10 to the 10th is really high, and I have stored those values, my mean and my standard deviation as such, and I'd come up with this value. Comes out to about 0.35195 and so on. But why don't I store that as P to help? I'm going to have to find out what this probability is, so I'm going to store that as P, right? And now my probability is there. Now I can come back to this binomial distribution. I figured out what my P is. It's right here. And then it asks me to calculate the probability that 2 is less than or equal to B is less than or equal to 4. So between 2 and 4. So I can go menu, probability 5, distribution 5. Mine's on the other screen. I'm going to do a binomial CDF. That's E. And I have 5 trials. I've put my P in here. So I'll put P in here. And my lower bound is 2, and it is equal to it, so it's good. Remember, this isn't continuous, this is discrete, so we got to be careful about our bounds when we have discrete. So, and then come out with my answer, and there you go. So it's going to come out to 0.569, 0.569, and there you go. So that's that one. Last one, it says a researcher thinks that the number of eggs E laid by the sparrows is modeled by a Poisson distribution with mean M. Given that probability that E, so we're looking at C here, the probability that those eggs are greater than or equal to 4 is equal to 0.9071. Correct the 4 decimal points. First, they want to find out what the value of M, because they didn't give us the mean, right? They told you that E follows a Poisson distribution with some mean, but we don't know the mean, so we have to find it, but they gave us a condition, right? And then since, you know, in theory, a Poisson distribution can go on for infinity, right? For infinity, you know, if we do greater than 4, it's going to be really hard to set up an infinite one. But I can write this as 1 minus the probability of E is less than 4, right? Now, if we're doing that, we want to make sure that we don't use the value of 4. And we could set up the equation for this and try to solve it that way, but it's pretty tedious, so we're just going to use the calculator. And we're just going to use the solver. So we're going to go algebra, numerical solve, and then I'll have 1 minus the Poisson distribution. So I'll go menu again, probability distribution. I have a Poisson that's on the other, and I want a CDF right here. Good. And my mean, since I've already I don't want to mess. I've already put m in here. I'm just going to use n instead of m. So I'll just write it right here. I'll use n, right? Because I haven't used that letter in there. And my lower bound is going to be 0, but it's going to go up to. You got to be careful here. It's not going to be at 4 because this is discrete because we did 1 minus this, so it's not going to be 4. So it's just going to go to 3. Enter. Enter. I got an error right now. That's because I haven't done the rest of the solve. What is this equal to? That's going to be equal to 0.9071, right? And I am going to define my variable as n, right? And then I am going to give it, I know it's going to be bigger than 1, so it's going to be bigger than 1. And I come out to here and I get my n. So I've just used the solver is equal to 6 point. They said 4 decimal points, so 1, 2, 3. So 1, 2, 3, 4. So it's 798.4, right? And that's what it comes out. And the last one, it says, give a reason why this distribution can't be an exact model in this case. Well, I mean, we're talking about birds laying eggs, right? And you know, they can't lay an infinite amount of eggs. So it's only accurate up to a certain point. What that is, I don't know. I guess I have to know more about those type of sparrows, the eggs that they typically do. But it's probably going to be a pretty good predictor up for first. I'm sure they average about 6, maybe a little bit more, but not too much more. So sound good, guys? Thanks.